Morning. Now we are going to see question number 4 from unit test. So we have in this question in a truss 4.5 meter long top chord members. So keep in mind, generally if top chord member if given, then it will be, if not mentioned, then you have to design it as a compression member. So you have to keep in mind always this. When this is given 275.8, now see this is unequal angle, and in this case we have to find both RYY, RZZ, we have same. Now we have given connection welded. Connection is given weld. So we have L effective, we have to take 0.7 into L, and L is given 4500. If it is bolted connection, we will take 0.85 into 4500, and we have this value that is equal to 3150 millimeters. Then we have to see the area of this. So this is 3150. Then we have d by t. So we have 100 divided by 8. So this is 12.8 ones are 8 to 100 by 8. 12.5, correct. 12.5. And then we have b by t. This is 75 by 8. So it comes 892 3. So which is both are less than 15.7. Then we have b plus d by t. So we have 110 plus 75 upon 8. So this value comes 23.12, less than 25. Therefore, section is semi-compact. Section is semi-compact. AE equal to AG. And this is equal to, we have value of A, that is 1340. So 2 into 1340. And this will be 2680 mm square. Then as we have this as angle section, so we have buckling class C. Buckling class C for angle section. Table 10. Uh, okay, then condition we have not given, that is connected on which side and all. So 0.7 L we have taken. Now we have to go for R value. So now try to understand this. We will consider 100 leg is connected to gusset plate. Leg connected to gusset plate. So what will be my diagram then? So I will draw it. So we are in this page. So greater connected to gusset plate. Greater leg. And then we have welding over here. And then we have y over here. And then that is y individual. Y all will be here. y whole. Then we have y individual here. And then we have this will be h value. What will be h? H is equal to Cyy plus thickness of gusset plate by 2. And what is value of Cyy? Just go over there. So you have this value 18.7 plus thickness of gusset plate we have to consider 10 and we will have this value 23.7 millimeter. And then we can find from this Ryy of whole section that is equal to root of Ryy of individual section square plus h square. Now we have Ryy individual 21.8. So we have 21.8 square plus h is 23.7 square and this value comes 32.2 millimeters. And this value is greater than RZZ, which is 31.4 millimeters. So RZZ is minimum, and therefore L upon L effective upon RZZ, which is minimum, and that is equal to 3150 divided by 31.4. And this value comes 100.31. Then buckling class C, so we have this value of FCD 100 and 110, 100, 110, this is L by R, and then we have this will be FCD 107, 94.6. And just you check it, I got value of FCD 106.4 Newton per mm square. And then we have PD, design compressive strength, AE into FCD. AE we have 2680, FCD is 106.4, and we have value of PD 285.15, 10 raised to 3 newtons, equal to 285.15 kilonewtons. So 2680 into 106.4. Yes. So this is main thing you have to see it. RZZ we have seen there is no change in RZZ. It is for individual also and this is for whole section also. Then we have another problem that is just I will again facing the problem actually. Then we have next question that is design a column 7 meter long to carry a load of 350 kilonewton using I section. The column is restrained in position but not in direction at both ends if not mentioned. That means we have this is pinned column and for pinned we have L effective equal to L which is equal to 7000 millimeter. Whenever you have single angle section, then your RYY is minimum. And therefore, for single I section, take FCD that is equal to 60 to 80 Newton per mm square. Go with 60 only. So I section I have mentioned in the class, but if it is built up section, is it single I section? So 110 to 140 that is for built up section. So now here we will go. So what value I have taken actually? I will check it just. So A required No, we will go with this. So we have A required then. A required equal to PU upon FCD. Now PU we have 350 into 10 raised to 3 and FCD we have considered 60. And then we have this value that is equal to 350 to the power 3 divided by 60. So it comes 5833.33 millimeter square. I have considered ISHB 225. Select ISHB 225. Now, when we have column, we have to go ISHB. You have to keep in mind, do not go other. 46.8 kg per meter. Now, we have to check B upon TF, which is equal to BF by 2 upon TF. BF we have 225 upon 2 divided by value of TF 9.1, and this comes 12.36, and we have this value. Just 1 minute, I will check this value less than. Actually, I forgot to check it at the time when I have its solution. So we have this is 15.7. So 15.7. So we have flange is semi-compact. Flange is semi-compact. So just I will check it. 225 by 2 divided by 9.1. Yes. And then we have D by TW. So D we have 225 minus 2 into 9.1, and value of TW we have 6.5, which is 31.81, less than 42, and therefore web is, now we have web we have to consider that is axial compression. So less than 42 epsilon, so less than web is also semi-compact. And therefore section is semi-compact. Section is semi-compact. And therefore AE equal to AG equal to, we have value of AG 5966 mm square. Then we have to go for buckling class, table 11. Buckling class, table 11. And in this, we have H by B. H by B 225 upon 225 less than 1, and then we have TF less than 100. Therefore, we have for XX axis buckling class is B, and for YY axis it is C, and therefore we have to take lowest. So we have buckling class C. Buckling class C. And then we will go with KL upon R. So we have KL upon R. So KL means L effective upon R minimum. R minimum is RYY. And then we have 7,000 upon value of RYY is 49.6. and it comes 141.13. We have to use table before this also, table 9C, and we have KL upon R FCD. So 140, 66.2, 150, 59.2. And solving this, we will get value of FCD. I will not calculate that. So we have 65.41 Newton per mm square. And then calculate PD, which is equal to AE into FCD. AE we have 5966, FCD 141.13. Sorry, 65.41. 65.41, and we have this value 390.24 kilonewtons. This value is greater than 350 kilonewton, which is Pu, and therefore safe. So provide ISHB 225 at 46.8 kg per meter as a column. So likewise, we have to solve the problems that is of beam section. So now we will stop here only. Remaining part we will see in the next lecture.